Okay, so we know what machines are on the network. What's the next step? Well, as attackers, we're probably going to want to pick a single machine to target. So in this case, when I looked at the machines that were on the network, I saw 10.0.0.11. That's not my Kali machine because I know that my Kali machine has IP 10.0.0.12. That's not my router. And so I can assume that that's going to be another machine on the network that I, as an attacker, can target. The first thing we're going to want to do as attackers is figure out what ports are open on our target. As a reminder, a port is just a way of segregating different services on a machine. So for example, I might have a web service and I might have a file service, both on the same machine. How do I know whether somebody's trying to access that web service or that file service? Well, we're going to assign each one a unique number. So in the case of the file service, let's say it's 21. And in the case of the web service, let's say it's 80. And then anybody who's connecting to me will say, hey, I want to access your service at this number. And that's how the machine will differentiate between different services being accessed. That number that's used is called a port. So if I'm trying to access the web server and it's sitting on port 80, I would reach out on port 80. In nmap, we can actually scan individual ports to see if there's a service running on that port. In other words, if that port is open. If I say nmap-p, -p allows me to select a port, and I'll just say 80 as my port in this example. And then I have to specify my target. I could, again, list a range of addresses like I did before when I was doing that host discovery scan. But in this case, I'm going to pick an individual target that I already know exists, and that's 10.0.0.11. Running that, you can see I get the result that port 80 is open, and the service that nmap assumes it's running is HTTP. Why does it assume HTTP? Well, because HTTP is traditionally associated with port 80. There are actually 3 different port states. So open means that that port has a service running on it that's accessible. You might also see closed or filtered. Closed means the target responded to us and told us that there is no service running on that port. However, filtered is when there's a firewall in place and the target didn't respond to us at all. So when we're reaching out to a machine and seeing whether a port is open, it has a few different options. It can tell us that the port is open and initiate a connection. It can tell us that that port isn't open and that there's no service running there, or it can refuse to respond to us altogether. And that third option, where it refuses to respond to us altogether, that would return a filtered state. So just to demonstrate this, I can actually target a port that I know is not open. So for example, port 111. And if I run this scan, you'll see that that machine responded to me and told me that that port is closed. Taking a look at the network traffic that is generated in Wireshark, let's first take a look at this when we scan that open port or port 80. If I want to view the full back and forth traffic associated with that specific action, I can actually pick any one of these packets. As you can see, here's a packet destined for port 80, and I can select right-click, follow, TCP stream. I'm going to close out of this window, and here we see the traffic associated with just that single exchange. You'll notice what happened is our attacking machine on 10.0.0.12 reached out on port 80 and sent a SYN. SYN is basically just a way of asking, hey, are you there? Then the target, 10.0.0.11, responded to us with an ACK. ACK basically is saying, yes, I am there. And then it also sent us a SYN saying, hey, are you there? Can you hear me? And we responded with, yes, I can hear you. And then we sent a reset, which tells it, I don't actually want to complete the connection. I don't want to continue communicating. I'm done. So this is known as a TCP handshake, this sequence of events. and we can see it very directly here in Wireshark. I'm going to close out of that filter, and let's take a look at what happened when we tried to target a port that was closed. Give me a moment as I find that here. So here, we scanned port 111. So here I see some traffic going to port 111. So to see that full exchange, I'm going to right click, select follow, TCP stream, close out of this window. You can see that this exchange was much shorter. This time we sent this SYN packet again saying, hey, are you there? But this time we sent it to port 111. And then the target, 10.0.0.11, responded to us saying, yes, I am there, but this port is closed, and it indicated that by sending back a reset. So this is how it looks like when an attacker scans an individual port to check if it's open. You see this handshake. This alone is not necessarily evidence of an attack, because legitimate users that are connecting to our services also go through this handshake process when they first connect. If somebody is trying to connect to us on a port that doesn't exist, like 111, that could potentially be suspicious, but somebody reaching out to us on port 80 and completing that handshake, that's not necessarily that suspicious, because that's what a legitimate user would do as well. I'm skipping a little bit ahead in this video. I actually went and I generated some legitimate traffic by browsing to that web page on port 80. I did that by opening up a browser and connecting to the target on port 80, basically just viewing the web page. So we can kind of see the difference between the traffic generated by this nmap scan and the traffic generated from a legitimate connection. So looking here, here's the new traffic that I generated. If I right click, follow TCP stream, I'm going to close this out. You'll notice that the beginning sequence is exactly the same. So we have this SYN saying, hello, are you there? The target responds to us with a ACK, I am there, SYN, are you there? And then we reply back with this ACK saying, yes, we are there, and then the connection can be started. When the connection is complete, we actually have this FIN ACK. So rather than the connection being reset, which is usually a hard stop and not really a graceful shutdown, in this case we have this FIN that's closing the connection. Seeing how this differs, the one thing you might notice is that the traffic that was the result of a scan actually sent this reset in the packet, whether it was our machine saying that the port was closed, sending back that reset, or whether it was the attacker saying, I don't care to fully complete the connection, I'm sending a reset to end it prematurely. In either case, there was this reset that was sent back and forth, whereas in the legitimate traffic, there was no reset. So one of the ways that we could potentially hunt for an attacker performing a scan is by looking for this reset. I can actually go up to this display filter here and say tcp.flags.reset equals 1. So this is just going to show us the traffic for which that reset flag was set to 1. And if I do that, I can see all of this, all of these requests from our attacking machine where it sent that reset flag, or from our target where it sent that reset flag back. This is a pretty good indicator, not necessarily 100% indication, but a pretty good indicator that it could be the result of an attacker performing a scan. And we could dig into this traffic further to learn more about it and see exactly what the attacker did. So if I right click on any of these packets and select follow TCP stream, I can see that exchange itself. I can also see the time around where that happened, and I can go back, dig into my network traffic around that time, and see what else the attacker may have done. Now we know how to scan an individual port as an attacker and see whether it's open or closed, but can we scan on a range of ports to see everything that's open on that machine? Absolutely. And to do that, I can actually specify a range of ports, just like we specified a range of IPs, by providing a beginning number, a dash, and then the end number. So for example, if I wanted to scan ports, I don't know, let's do 20 through 23, I could say 20-23. I can also comma separate ports, so if in addition to this I wanted to also scan port 25, I could put a comma and I could say 25. And then this will do the same thing, but it'll do it for ports 20 all the way to 23 and additionally port 25. So if I run this, you can see I get the data from ports 20 through 23, 2 of which are open, port 21 and port 22, and then additionally for port 25, which is also open. While that's useful, maybe you want to scan every single available port. And if you're familiar with networking, you'll probably know that the entire range of ports that any machine can use goes from 1 all the way up to 65535. So one way I could do that is I could type out 1-65535, and then that will scan the entire port range. There's actually a shorthand method of doing this, and that's just to put the dash by itself. If I just put that dash but don't put the 1 in the 65535, nmap will go ahead and scan that entire range of ports and tell me which ones are open. I'm not going to do this yet because I actually want to add a few additional flags to this to make the scan faster and to gain some additional information, and then I'll show that at the end of this video. The next thing I want to take a look at is what information I can get from these open ports. So perhaps I know that port 21 is open, but let's say I want to know the version of the service that's running on that port. I can do that with nmap by adding the -sv flag. Now that I added -sv, nmap's actually going to reach out on that port and try to get the version of the service. The way it does that is actually by interacting with that service. And when it interacts with that service, it sees how it behaves, or it sees what kinds of information it returns. And from that, it takes its best guess about the version of that service. Nmap isn't always going to be 100% accurate. It's just taking its best guess. So as an attacker, you're probably going to want to connect to that service and verify that it is actually running the version that Nmap says it's running. The other thing we could do is we could add -sc. In addition to getting the version, -sc will tell Nmap to do more things with that service to give us some information about it. Nmap actually has a set of built-in scripts that attackers can make use of to learn more about individual services. -sc tells Nmap to use the default scripts associated with that service. So for example, in this case, the first thing Nmap will do is it'll check if port 21 is open. If it sees that port 21 is open, then it'll try to figure out the version of the service running on port 21. It'll do that by connecting, probably using FTP, since port 21 is associated with FTP, and it'll see what kind of response the server returns. When it's tried its best to identify the version of that service, then it will go ahead and, knowing that service, it will run some additional scripts that will pull down more information about that service. Running this scan, it may take a little longer to get back to us because it's performing these additional, it's looking more into the service than it did before. In this case, we didn't get much extra information, but let's say I choose a different port like 80, for example. In this case, we got a little bit of extra information, like, for example, the title of the page that's hosted on port 80, and also the server header, or the actual header that the server returns back to us when we connect to it, which in this case confirms that the version that's being run is Apache 2.4.59. Taking a look at that scan that targeted port 80, the first thing it did is check if port 80 was accessible or was open. So here we see the full sequence of events, the SYN-ACK, ACK, and the reset ACK, right? And that's the same sequence of packets that we saw before when we just scanned the port itself. From there, nmap connected to it just to grab the service version. So if we click on this traffic here and do follow HTTP stream, we can actually see nmap reaching out, just asking for the main page, and then we get the response from our target. And you'll notice that that response contains the version Apache 2.4.59. So from there, nmap could infer that the target is in fact running an Apache server with a version 2.4.59. After that, nmap continued to reach out and perform some additional checks. Those additional checks were due to the other scripts that were associated with that protocol. In this case, it doesn't really look like it did anything interesting other than grabbing the main page, but you can see that it ran all sorts of different checks to learn more about the web service. You can see, for example, here, it looked for some potentially common paths that may be available in HTTP. So here we see a request to evox about. However, that returned a 404 not found error because that page actually doesn't exist. What exactly nmap is doing under the hood is not super important, but the point is that everything that nmap does generates traffic that defenders who are monitoring that traffic can then see. I'm going to take this scan one step further, and I'm going to perform it for the entire port range, so from 1 to 65535. I'm going to do that by replacing 80 with that dash, which tells nmap to scan all ports. I'm going to leave -sv and -sc to get the version of the service running on each of those ports, and also fingerprint those ports a little bit more to learn more about them. However, I'm going to add a couple additional flags to make the scan run faster. nmap can actually run a scan at various speeds. What I mean by that is how often nmap reaches out to the target and how long it waits between times that it reaches out. The faster that nmap reaches out to the target, the faster that our scan runs. However, at the same time, we don't want to go too fast, or we'll either overwhelm the target and it won't be able to reply back to us, or somebody who's sitting in the middle and monitoring network traffic will very clearly see that we're performing a scan. So those are two reasons why you would maybe want it to go on the slower side. nmap has a series of timing templates that it uses to decide how fast it scans. And those templates, don't quote me on this, but I believe they go from 1 to 5. 1 being the slowest scan, which is super stealthy, nmap will only send traffic back and forth every so often, and so it'll be hard monitoring the network to really see that. Versus nmap's template 5 on the other end is the fastest scan. However, the problem with that one is sometimes it overwhelms the target and we don't get accurate information back. By default, nmap strikes a balance by choosing template 3, which is directly in the middle of 1 and 5. However, I've found from testing that template 4 tends to work just as well and bring back equally as accurate results, but it runs a little bit faster. So in this case, where I'm not really worried about being stealthy and I'm not really worried about overwhelming the target, to make the scan run a little bit faster, I'm going to use timing template 4. In order to do that, I'm going to say -t and I'm going to add a 4. There are a couple of other things that nmap does before it actually starts scanning the ports on the target. The first thing it does is it checks if it's accessible with that ping scan that I showed you how we ran initially. Remember how I talked about it's not really a ping scan, nmap just calls it a ping scan. It really does takes a bunch of different information into consideration to determine whether that machine is available. However, we already know that machine is up because we already scanned it before, so we can avoid this step by adding -PN, which tells nmap to just assume that that machine is up and running and that it's accessible. The other thing that nmap does is it actually takes this host or this target that we provide it with and checks if it is a domain name that can be resolved to an IP address. In this case, we're specifying our target directly as an IP address. If we were specifying our target with a domain name like google.com, then nmap would have to resolve that. However, because we're directly giving it an IP, it doesn't have to perform that check, and that check just wastes time. So to avoid that check, I'm going to add a -n. -n tells nmap, do not try to resolve this to an IP address, because it already is an IP address, so just treat it that way. The last thing I'm going to add is -vv. So -v is very commonly found as an argument for many different commands, and it stands for verbosity. Verbosity is basically how much the command talks to you while it's running. So the thing with nmap is when you're running a scan that takes a while, nmap's not going to tell you what's going on as it's performing the scan. Instead, it'll wait until the scan is complete and only then give you back all the information. However, I like to see what nmap is doing while it's doing it, because as an attacker, that could save me some time. For example, if nmap discovers an open port like 80, but it hasn't completely finished its scan yet, as long as I know that it's found that open port, I can already start investigating it without having to wait for the scan to finish. This is where adding that -v to increase how much nmap talks to you, or to increase verbosity, is very helpful. nmap has a few different ranges of verbosity, so 1V is only going to talk to you a little bit, 2Vs is going to talk to you a little bit more. I personally like to use 2Vs to have nmap talk to me a reasonable amount while it's running that scan. The last thing I'm going to do is save that nmap scan to a file. So there are 3 file formats that you can save scans to. And this is useful as an attacker if you perform the scan and then you want to reference it at a later time. You don't have to scroll up in your terminal and try to find where that scan occurred. You just have it already saved to a file. The first file format that nmap supports is normal format. Basically, that puts in the file exactly what you would normally see if you were to just run the scan. There's also a greppable format that allows you to use grep to actually search the contents of that file. And last but not least, there's the XML format, and the XML format allows you to parse that nmap scan with other tools, for example, converting it to something that you can view in a web browser. If you want to write a file to all 3 of these formats, so you want to write a normal file, a greppable file, and XML file, you can add -O, capital A, and that stands for all. And then you put the actual name of these files. So in this case, I'll name these files scan. I know this was a lot. I know I just went through a bunch of different options in a short sitting. If you're ever curious what these options do, again, you can always run nmap-h and you can get that information. However, when I, as an attacker, scan a machine that I don't know what's on it for the first time, this is the full nmap scan that I personally like to run. What this scan will do is it'll go through all the ports 1 through 65535. It'll tell me the version of the service running on each of those ports. It'll give me a little bit of extra information about each of those services. It'll be a little bit faster than the default nmap scan, and it will assume that the target is already up and that we can just connect to it. And it's going to also print out some additional information while it's running and save the results to 3 different files: the normal file, the greppable format file, and the XML file. Anyway, now that I run this scan, this may take a little bit longer to run because now I have to go through every single port from 1 to 65535. You'll notice as it's scanning, because we specified -VV, nmap went ahead and printed out the open ports that it found. So as an attacker, knowing this information, I can already go in and I can start targeting those ports. Like, for example, port 80, which I know is associated with web traffic, I can go to my web browser and take a look at my target 10.0.0.11 on port 80. And we can see this takes us to the Apache 2 Debian default page. Once the scan is done, it's going to print out all of the scan information that I can see here. For each service, it printed out the version of that service and also some additional information associated with that service that can help me as an attacker, understand what to focus on next. This is a lot to look through, and if I ever want to come back to it later, I can always open up one of those files that I saved. So if I ls, you'll notice I have a couple different files. You can ignore passwords.txt and usernames.txt. That's going to be covered in later videos. But I have these scan files that this nmap scan generated. So the basic nmap scan, if I ever want to read the output from that again, I can say cat scan.nmap to print out that file. And this gives me basically the same information that we saw before in the terminal. If I want to search and see if a specific port is open, that's where this greppable one comes in handy. So for example, I can say grep, and then I can search for port 22 in scan.gnmap. And if port 22 is in fact open, you'll notice that it tells me that port 22 is open and that the associated host is 10.0.0.11. So it's really easy to search it that way. If I wanted to check, for example, a different port that isn't open, like 111, which I know is closed, if I try to search that, nothing comes up. So that's where this greppable nmap scan is very useful. And then taking a look at the XML, if I just print that out, by itself, this XML isn't necessarily very helpful, but we can actually convert it to a really nice format that we can then open in a web browser. Fortunately, there are already tools in Kali that will do that for you. One such tool is XSLT-proc. So if I look at XSLT-proc, there are a lot of different things you can do with it, but one of the things I can do is I can actually convert that XML file to something that can be open in a web browser. So if I say XSLT-proc, and then I specify the name of that XML file, scan.xml, and then I want to output it as, I'm going to double check if the option is -o. I'm pretty sure it is. Yes, so -o. I want to save it as scan.html. HTML is a type of file that can be opened in a web browser. Now if I go ahead and list out the files that I have in this directory, you can see I have this scan.html file. I can open it in a web browser by saying Firefox. Firefox is the name of the web browser that comes installed by default in Kali Linux, and then the name of the file I want to open, so scan.html. Taking a look at this file in a web browser, you can see that it prints out the same results that we got from our nmap scan, but in a much easier to read format. So you may prefer to actually look at the results of that scan in a web browser rather than digging through that scan.nmap file. Taking a look at what our scan looked like from the defensive perspective, from somebody who's monitoring the network, we can actually see the scan in Wireshark as defenders. So the first thing you can see that nmap did is it did a bunch of reaching out to different ports. It tried each of these ports one by one, and for most of them, it just received the response that the port is closed, and we can see that here. So if you see a lot of these reset requests being performed in a short time frame, it's very likely that an attacker is scanning your machine to see which ports are open. After nmap scanned to see which ports are open, the next thing it did is it reached out to each of those services on those ports to gain more information about that service. How it reached out really depends on the service itself. So in the case of HTTP, which is running on port 80, it reached out using the HTTP protocol. In the case of SMTP, which was running on port 25, it reached out using the SMTP protocol. And you can see that it generated all this traffic associated with the scan. As a defender, you can get pretty creative in trying to see whether an attacker is performing an nmap scan against your machine. So one of the things we can take a look at is, let's take a look, for example, at this SMTP. Let's see what the scan actually did. So if I right-click, say, follow TCP stream, you'll notice that the nmap tool, it connected to our SMTP server. Our SMTP server returned this nice banner that told it that this is postfix. And then the tool announced itself. If you're familiar with how SMTP traffic works, the first thing you have to do is announce yourself, and the tool announced itself as nmap.scanme.org. So this is an example of how knowing the tools that attackers are using can help you as a defender come up with indicators of compromise or indicators of attackers using those tools. So knowing that nmap, when it connects to SMTP, sends this hello and provides its name as nmap.scanme.org, we can actually go ahead and we can search our traffic for any occurrence of nmap and potentially find places where an attacker is using nmap to scan our SMTP service, right? And so, for example, knowing this, I can actually go ahead and I can say edit, find packet, and I can search for I can search for nmap. I'm going to change this to a string because we actually want to search for the string nmap. And I'm going to change this to packet bytes because we actually want to search the contents of the traffic itself. If I click find, that'll take me directly to every place where nmap announced itself as being nmap. And you can see there are a lot of different places here where nmap announced itself by putting nmap somewhere in the traffic that was being sent back and forth. So looking at this right here, if I right click follow HTTP stream, you'll notice that in the user agent, it actually says nmap scripting engine. So that's a very clear indicator that an attacker was scanning us with the nmap scanning tool. You can get creative and take a look at, try these scans out yourself, take a look at the kind of traffic these tools generate, and come up with another way of potentially detecting when an attacker would use that tool. I showed you one example, which is searching the packet details for any occurrence of the word nmap. I also showed you that other example of searching for any packets that contain that reset flag, but you can be creative. You can come up with other ideas for different ways of filtering your traffic to find when an attacker is performing a scan. Remember that a scan is not actually an attack. So just because an attacker scanned you doesn't mean that they gained access to your machine. That just means that they're learning more about your machine and potentially what it can do. But if you see that an attacker is scanning your machine, it's very likely that shortly after that scan, the attacker will be trying to do something malicious to get onto your machine.